People that just joined, welcome once again. This is our first webinar on smart robotics. Today we're going to talk about overcoming e-commerce warehouse challenges and by using smart robotics. All right. Hey, thank you everyone for participating. We'll give it a few more seconds before we end this poll. All right. Okay. All right. End of the poll. Thank you very much, everyone. And now let's move on. With us today, we have, as I mentioned, Johnny Chang. Johnny Chang is very excited to share all his knowledge. He, as I mentioned, is the Vice President of International Sales for Hai Robotics. He has over 14 years of experience in working in large international corporations. And he is here with us today to talk about smart robotics. Johnny, welcome. Hello, Johnny. Well, it seems we have some technical issues. Wait a second. I think we have some technical issues here. Okay. All right. Here's Johnny. Hello, Johnny.
Yep. Yeah, Jonathan.
Sorry about
that. Can you hear me?
Yes, I can hear you.
Got it. All right. Thank you, Jonathan, for the introduction. And welcome to the Smart Robotics webinar, where we will explain smart robotics solutions that can help e-commerce warehouse. My name is Johnny Zhang, and I've been working with smart robots and warehouse automation for a while. It's my honor to have this opportunity to share my understanding and the vision of how smart robots can help industry customers, especially in e-commerce area. Yep, this is the agenda for today's webinar. Basically, the first thing is we want to...
Excuse me, Johnny, I think we have a little problem with your video. Could you check, please?
Yeah, of course.
Is it working well?
Yep.
Oh, there we go. There we go. Yep. Sorry, everyone, for that technical issue. Here's Johnny with us. All right, you can go ahead.
Sure. So here's the agenda for today's webinar. The first one is the market situation. I'm gonna explain what is the current difficulties the e-commerce customers are facing. And the second one is I'm gonna briefly introduce what kind of available solutions for the e-commerce customers at this moment. And then we're gonna talk about why the customer should consider this new technology. And the number 4 is the Hai Robotics introduction. We're gonna briefly tell you what kind of products we have and what kind of application, what kind of scenarios we can deal with. And the next one is 2 case studies, as Jonathan just mentioned. So both of them are e-commerce and also the B2B business combined together case study. Then we go to the Q&A section. Now let's go to the market situation. Right. So based on this is a very interesting market research from McKinsey in the middle of this year. So which lists the 5 industries in 10 major economies. Then you maybe notice the blue means growth on e-commerce and the red means decrease on e-commerce. Then you can see besides Germany, Japan, and China, e-commerce in all other 7 economies increased. And for China, maybe everybody already noticed because the Chinese government did a pretty good job on control of the virus. So basically, all the stores, all the stores are already open. So maybe decrease a little bit for the e-commerce. So, but overall, you can see global wise, you can see the online e-commerce increased 10% global wise. Then I'm going to talk about how COVID-19 propels warehouse automation adoption. So based on the feedback from the market, we found some interesting info I want to share with you. So the COVID-19 actually is changing the mindset of company have been resistant to warehouse automation. And of course, no need to mention the rising demand for shipped goods. And basically, I think most of you already heard back to April to May, Amazon piled up maybe double or triple of the orders in their warehouse, but it's to be shipped because a lot of things, because the capacity to ship out those kind of stuff. And also the social distancing requirement make automation became nearly necessary. And also people feel reluctant to work in the warehouse, make the situation worse in terms of the labor shortage. And also, I also noticed during the COVID-19 time period, most of the government trying to boost the economy to announce very attractive policies such as lower down the interest rate. So the low cost of financing actually makes the ROI attractive. So you can see some e-commerce orders in daily base increased 50%, and the electronics increased almost 60%. But if you're looking at the groceries, that almost doubled. All right. Then let's talk about current available solution in the market. Then I think most of the customers already noticed, already very familiar with the current technologies, such as the AGV, collaborative robots, and also the AMV, ASRS. So I'm gonna focus on what is ACR, why we call it ACR. So basically, ACR means autonomous case handling robots. And we use the data-driven and also the AI technology, AI algorithm behind it. So the whole operation will be a data-driven, fully automatic solution for the customer, for the operation. Then I'm gonna do the further comparison in later slides. Then here's the brief video to further get your audience with some ideas how our system works. Sorry, maybe a little bit lagging, but just want to try to get a concept of this, of our system. You can see the camera will read the DM code, not just for the shelving but also with the totes. And this is the interface between the picker and our robotic system. Software, how simple the DM code, assembling, and also the working logic. Yep, just through this brief video, I want to get you more ideas of our system. When it comes to this, it's very interesting cost performance system comparison. Then you can see the ASRS and also the collaborative robots, so-called PAMR. That is the two ends of the existing technology. Of course, ASRS is very good, but the cost is also very high. But the collaborative robots, the cost is okay, but the performance is low. So I think we are looking at the middle ground. And fortunately, I think ACR just got the relatively good performance, but also relatively low cost. And if you're looking at the position of ACR and also the ASRS, you can see there is a big area overlap, which means we can take a portion of the ASRS business with fairly low cost. All right. Then let's zoom in a little bit and further compare the efficiency, storage, and the construction time and the payback period between several major technologies. And from the bottom, it is the ASRS, which already exists in the market for decades, which can deliver good efficiency and the storage density. But the downside is also very obvious. So the construction time usually takes about 18 months, and plus several months more for the commissioning and also the software side. And also the flexibility. I don't think there's any flexibility for this kind of solution because that's a heavy construction project. And one more thing for the lack of the flexibility is if anything wrong with the ASRS, the whole operation will shut down. So that can be a disaster for operation. And the second line from the bottom is the robotic collaborative, like the brand Locust, Six River, and Fetch, those kind of brands. Actually, I don't think they are our real competitor at all, because their working logic is they divided the different zones in the warehouse, and a certain amount of the collaborative robot work with the people, follow the people, help the people, assist the people taking the totes and items. But you're looking at, if you look at the overall warehouse operation, maybe you know, especially in e-commerce, you will find specific zones. Some zones are very super busy. And but besides those zones, other zones have nothing to do. So if you're looking at the overall performance of collaborative robots, that's maybe not a good approach. Then we goes to the AMR, like Kiva style, like Green Orange, D+. For some of the scenario, goods to person scenario, they can deliver fairly good efficiency. But the major difference between the AMR and ACR is, as I mentioned, we can reach double or triple of the height of their shelving. So basically, we can deliver very good storage density. And another thing is for the if we're talking about deeper dive technology comparison between AMR and ACR, the working logic or the mechanism for the AMR is they bring the shelvings to the picker, but our ACR bring the totes. I'm going to show a bigger picture about ACR later slides, but you can see because the AMR will bring the shelvings, but the heat rate can be fairly low. Because if we're looking at a large number of SKUs in one application or one operation, maybe the heat rate for the AMR is between 1.2 to 1.6. That's it. But for our robots, I think because we bring the totes, and each of the totes can deliver one useful SKU at least. So if we can carry 9 totes in one run, you can imagine what is the heat rate increase than the AMR. Right? I think that is the technology comparison. Okay, then we goes to why ACR. Why the application is to looking at ACR. All right, so let's talk about the pain points of traditional e-commerce warehouses operation. So the first thing is, of course, the operation efficiency. Because if we're looking at the global market, based on our data, 95% of the warehouses still stick with the manual operation. So the manual operation causes a lot of problems. So the low picking accuracy and how to deal with the high number of SKUs, and also the single order fulfillment, or maybe few order fulfillment, few lines of order fulfillment. That can be very challenging for a pure manual operation. And also the storage space, because if the manual warehouse, if that is a purely manual warehouse operation, the storage space and the storage height will just should be compatible with a human being. So which means usually the shelvings can just reach about 2 meters high at the most, and we use and even higher they use a ladder, but they will further decrease the efficiency and the storage density. But also the high rental cost, that's highly related to the storage space, because they didn't fully utilize the storage space. So which means they're gonna rent, the customer to rent a larger space for the operation, especially for the urban area, like the big cities, around the big cities. So that can be a big problem. And another thing is for the traditional way is the low flexibility. It's very difficult to make any modification of it. For example, I think right now the business is very dynamic. So no matter that is a 3PL or maybe the e-commerce service provider, maybe this year the customer need maybe 10,000 square feet this year, but maybe next year they're gonna need 1.5 times, or maybe double of the space. So it's very difficult for the customer to make this kind of switch. Right? Go to the next slide. Then, what kind of benefits we can do? So of course, because this kind of cutting edge boost-to-person technology, we can increase the productivity, because the people don't need to walk in the warehouse and instead just wait for the robot bring the useful SKUs. Then because the hit rate and also our price strategy, the cost of the project, the overall cost of the project can be really reasonable. And also, as I mentioned, the construction time compared to different other technologies, even with other robotics, the construction time can be very quick. I'm gonna show you on the later slides. And also the flexibility, because each of the robot will work individually, so we can always deliver the flexibility. For example, if anything wrong with one robot, then it will not significantly influence overall operation. Then I think the labor shortage is kind of like a global-wise problem, even in China. So I think the warehouse automation can be a very good supplement for this to deal with this kind of problem. Then another benefit for the customer and for the no matter that is a 3PL or e-commerce service provider, our solution always can get you a small start. It's not like the ASRS. There's no small start at all. So which means you can just buy a few robots to do a pilot project or a POC project. And after we prove the concept, then you will make the decision of a big project. Then the brief introduction of our project, how we're going to deliver our projects. Basically, we're going to do two lines. The first line is the hardware. The second line is basically the software. So I think both of the lines can be proceed simultaneously. I think at the same time we can do the hardware manufacturing and also the software development in order to deliver the projects as soon as possible. And next slide. Then our product introduction. So right now we already have four product lines. The first one is our standard ACR Hypec A42. This is a single D with a tote-based ACR. Second one is double D ACR, which means we can put 2 bay of racking back to back. The ACR cannot just grab one tote, but it also can grab the second tote behind it. The third one is a carton picking ACR, which means the customer don't need to buy the plastic tote, invest on the plastic tote anymore. And of course, if the customer prefer to use that, we can have our carton picking ACR can work with both carton and the totes. And the last one is our newest product, telescopic lift ACR. This ACR can reach 6.5 meters, which is amazing. So I think with this kind of technology, maybe we can reduce 50% of ACR business in global wise. Right, next slide. All right, so a portion of the projects we have done in the market, global market. This slide just to demonstrate we will be a very good fit for the 3PL business, and also the obviously e-commerce business, and also the retail. And next slide. Further demonstrate we are not just can fulfill the requirement from the logistic scenario, but also we can do the manufacturing working scenario, pharmaceutical, electronics, and also the energy industry. All right. Just to quickly summarize the 3 major advantages for our system. As I mentioned, we always can do the faster deployment, but how fast we can do. For certain projects, we can fully automate your warehouse within 7 days. Why is 7 days? Can be as short as this. It's because our design of the solution is very straightforward. We leave the difficult job inside of our organization, our company, but leave the convenience to the customer. So basically, when we talk about the deployment, we only talk about the shelving, assembling, and also the labeling of the DM code, and also the totes. That's it, right? So then we talk about the multi-tier steel platform solution. Basically, we already have this kind of solution ready for the market. If you want to any client want to further increase the storage density vertically, maybe we can do a multi-tier of the solution. Basically, the concept is we build a workstation always on the first floor, but our robots can work on the 2nd floor, even 3rd floor, and we use the conveyor to transfer the totes from the different layers to the downstairs 1st floor. Then we do the picking, and we return those throughput, put it back. So that's pretty much the logic. Then our high robotics introduction. So what kind of service we can provide? Let me just further explain that. So basically, we can do as I mentioned, we will, in order to deliver the solution to the customer, we will do the warehouse planning. We're gonna deliver the solution to help the customer transfer from the traditional manual warehouse to a fully automated AI technology encrypt solution. And the second thing we're gonna do is, of course, add system integration. It's not just about the hardware, but also the software side. We're gonna connect with the upper level software such as the WMS like Manhattan, or maybe ERP like SAP. And also for the hardware construction, hardware connection, we're gonna connect with the conveyors, other equipment, maybe the robotic arms. So we're gonna do the integration of the project. Then we're gonna do the manufacturing, and I think most of the products, especially the robots and the charger, we manufacture by ourselves. And then we do the, as I mentioned, we do the deployment by ourselves, and also we do the UAT testing. We do the project handover. But that is not the end service we provide. After we hand over the projects, of course, we're going to provide a professional grade of the customer service. And we're going to sign the SLA agreement, service level agreement. We're going to categorize all kind of issues and problems, and then always deal with that in a very good timely manner to guarantee the performance of our robotic system in any time. Right? Then next slide to demonstrate what our systems looks like. In the middle, that's our robot and shelving totes. In the left-hand side, that is the intelligence charging station. Basically, our robot will go back to charge the battery automatically. And the right-hand side, that is the typical workstation layout. You can see we can just put a very simple touch screen with a computer and the photo-light wall. And also we developed a high-Q system as our software by ourselves. All right, slide. Then we're gonna do 2 case studies to further compare, to further demonstrate what kind of performance we can deliver to the customer. Then the first one, actually, we led the project in Shanghai warehouse with a very famous 3PL. This is a fashion apparel brand customer. And based on the requirement for this operation, it's not just about the e-commerce business, but also the project will cover the B2B business as well. So which means the project will fulfill the B2B business orders and the B2C business orders as well. Then I'm sorry, Jonathan, is that possible to back to the, yes. Main points for this project, of course, that is before they equipped with our system, they just stick with the manual way. Of course, as we mentioned, the low picking efficiency and accuracy, a lot of mistakes happen during the piece baking, and also the high security standard required because this is a very high-end customer. And also the shopping events, for example, Double 11, Double 12 in China, they always need to experience the peak time. That's always caused a shortage of the labor. Then next slide. And we can, Jonathan, is that possible to show a video here? All right, perfect. So just to give you a further concept, what kind of solution we deliver for this product. And obviously we provide the racking system and also the software system, and the most important, sorting and picking system. Which means this project we implement 9 robots with 3 workstations. And a very simple before and after comparison. And for the accuracy, this is the most important thing the customer will focus on. Basically, after this project landed, the picking accuracy increased a lot, and actually it is close to 100%. And of course, enhance the security with automation with this high-peak operation. Storage capacity wise, I think this is almost we almost double the storage capacity. And for the efficiency wise, for the storage, for the inbound efficiency, we increased 20 times. If my memory is correct, before they implement this project, that's about 120 or 150 pieces per hour for inbound. But after we implement this project, that's 2,500 pieces per hour. And then the outbound efficiency, that's 3.5 times. And as I mentioned before, we did a very good job on the deployment. I think the whole project, we finished that within a month. All right, so the next case study is the best supply chain, which is one of the largest supply chain company in China. It's also an apparel warehouse. The warehouse serves a famous fashion apparel brand, and for this project, it's more focused on e-commerce business. So it's the operation team runs in the large warehouse and handles a huge amount of the outbound orders. The pain points for this project is similar like previous one, but the only major difference is compared to the previous one is this operation. There's no any data IT system yet. So basically, we help the customer to build the IT system and bring the upper level software as well. So of course, we increase the efficiency and decrease the errors on the picking, and also the storage density increased almost double, and also we meet the target of the one month deployment. And next slide. Yep, the solution we provide is the high-peak robots, racking system, customize the software system, and also the sorting picking system. All right, the before and after comparison, the efficiency increased by 4 times, and the storage density increased 80%. And as I mentioned, 1 week deployment, 3 weeks testing, 1 month go live. Then easy conclusion based on those two projects, and also the information I provide in early slides. So what kind of solution, what kind of scenario will be a good fit for our solution? I think robotics solution. So if we're looking at a large number of SKUs and items is very small, can be fit into tote, regular tote size, regular size of the tote or carton, and high throughput, a lot of piece picking operation involved in the operation, and a single or few lines order fulfillment, and high level of security required because we only need to spot the workstations. So it is not necessary to meet all those 5 features of the operation. Even just 1 or 2, that can be then it's highly possible for us to deliver a very reasonable and a very good solution for your customer. All right, Jonathan, I think that's the major thing I want to talk about today. Take it over.
All right. Well, thank you, Johnny. Thank you for your for all the information that you have provided today. It's been very, very helpful. I hope all the viewers have got a lot of information about robotics, about this new solution High Robotics is offering. And we encourage everybody right now, if you have any questions, we have received a few, but if you have more questions, just please write it in the conversation in the Q&A option, and we will try to answer right now we are entering actually to the Q&A segment of this webinar. And the idea is that we can help you solve any questions, any doubt that you may have. The idea of this webinar is to provide all the information that we can, so it can be beneficial for your warehouse. So Johnny, it was very, very interesting. I think we got some questions right now, and what we would like to go through them. Maybe you can help us answering some of them.
Sure, of course.
All right. We remind everybody that please, if you have questions that you would like to ask later, you can also contact us, and we will arrange someone to send an email or contact you directly. So let's go through the questions first. And the first one is a question related to the system, the HiQ system. And it says, what WMS / ERP systems can be integrated with HiQ system?
All right, very good question. Basically, we work with most of the major softwares in the market. If we are talking about WMS, such as Manhattan, or ERP like SAP, we already have the mature solution to connect with those kind of major software in the market. And besides that, we also work with other medium to small software companies because we are working with many customers global-wise. So, and we connect with both systems with the API development. So, which means no matter what kind of software customers using, upper level software customers using, I think we have the capability to develop the API for them. And even in some extreme case, customer don't have any WMS or ERP system as their IT system or all the processing warehouse management system, IT system. We even can also use the Excel to input the order lines to our system. So we can be very flexible.
All right, thank you, Johnny. That's actually very helpful. The flexibility in all the solutions, not only from our solutions, but in general, warehouses sometimes have this kind of issues, and they have to move to somewhere else, or they have to use different systems, or they have to change their goods. That's actually very helpful if we can have this type of solutions. So let's go to the next question. We have, it's about the robots. So about the Hypig robot, what is the performance of the robots, such as maximum speed, acceleration? What is the performance in general, Johnny? Could you tell us about that, please?
Got it. So if we're talking about performance of our robotic system, I think everybody care about the speed, how fast our robot can run, right? Even with many cases on the back. So I think our master speed is 1.8 meters per second, which is very fast. So, and that's another reason we don't prefer the robot. We work with the people. Mm-hmm. So in order to deliver the efficiency. And if we're talking about the average speed, that's 1.5 meters per second as an average. So we can take this number as an operational robot running speed. And the efficiency-wise, normally we state 25 to 35 toes per hour per robot for outbound, depending on the workstation type selected. For inbound, we typically we would generate even higher productivity. Based on those two case studies I just present, I think usually we deliver between 15 times to 25 times the inbound efficiency increase. And to further calculate the efficiency of our robotic system, I think we're gonna do we have based on the Excel tool, and also even we have the software simulation. So I think we can deliver a very good, very accurate performance report after we receive the data from the customer.
All right, thank you, Johnny. We have another question here. It's about the charging time. How long will it take to fully charge the battery of the robot?
All right. For fully charged, I think that is 1.5 hours. For 5.5 hours, 1.5 hours charging to allow the robot to run 5.5 hours. But basically, it depends on the charging window, which is selected as part of the charging strategy. Normally, based on our testing, normally we operate the batteries in the 30 to 80% window to, for the battery lifetime to enlarge for the battery life purposes. I think based on this kind of strategy, if we only charge from 30 to 80% of the battery, it only requires 35 minutes. So in this way, maybe 35 minutes will allow the people for the will allow the operator to operate for the first shift in the morning, and during the lunchtime, then the robot will be fully charged. Then allow our robotic system can work non-stop for the next shift.
All right. We have another question, Johnny. This is a double question. So we will start with the first one. And one of our viewers is asking, he wants to know what's the average amount of totes that one ACR can carry to picker in an hour. And is there any other way to improve this data?
Yep, very good question. So I think I mentioned that earlier regarding to how many totes we can deliver within 1 hour per robot. It depends on the what kind of workstations we deliver to the operation. Typically, we can deliver from 25 totes to 35 totes per hour per robot. So which means if a system carry 10 robots, then they can deliver between 250 totes per hour to 350 totes per hour for one robot. And typically, what is the number to match between the robots and the station is three matches, which means if we're looking at 10 robots workstation, 10 robots, then we're looking at about 3 workstations. So to summarize the answer, that's 25 to 35 totes per hour per robot.
All right, and the second part of the question says, our viewer wants to know the amount of how the amount of ACR robots is determined in a project. How do you choose, okay, for this project, we need X amount of robots. How do you do that?
I'm sorry, is that possible to repeat your question again?
Sure. Our viewer says, I want to know how the amount of ACR robots was determined in a project.
Okay, so how are we going to calculate how many
Yes.
equipment are going to be in, right?
Exactly.
All right. So basically, the logic is very simple. According to the order lines, the customer assign our system want our system to digest. For example, maybe 1,000 order lines per hour, or maybe 2,000, or even more. So based on all the lines, we're gonna analysis the order profile. Then we're gonna figure out how many totes our robot will bring from the storage area to the picker. Then we're gonna calculate the efficiency of the workstation. Basically, the human being. What is the efficiency of the human being? Then, based on all those kind of data, then we're gonna figure out how many robots will be needed, and how many workstations will be needed, and how many shelvings and totes will be needed. So it's all based on the requirement of the operation.
All right. We have a few other questions. I want to encourage again everybody here who is watching this webinar. Please send us your questions. Let's take advantage of this time, this moment. We have Johnny Chan right here, Vice President of International Sales, who can help you solve any of your doubts. And we have another question regarding the workstations. What kind of workstations do you offer, or does a Hypex system offer? Johnny?
All right. So I'm sorry. I apologize. I didn't put the different kind of workstations layout into the presentation, but maybe I'm gonna do next time. So so right now we have 3 options for the workstation. During the video, I think this is the first kind. That is the picker will pick the items directly from the robot. And we also can have the second option. The second option will be the U-shaped conveyor. So the concept is each of the workstation will be equipped with a U-shaped conveyor. Then the robot will deliver the tote to the one end of the conveyor, and the picker will stand in the middle of the conveyor. Then after the picking, the totes will transfer automatically to the other end. Then our robotic system will pick the totes and bring it back to the storage area. The third option is the buffer shelving. Buffer shelving besides the workstation. Basically, the interface between the human being and also our robotic system is shelving. So basically, our robot will bring the totes and put down the buffer shelving and leave. The robot will not wait for the picking. And after the picker pick the items, then bring the totes back to the buffer shelving wall, then our high-pick robotic system will bring the totes back will do the put away. That's the 3 different kinds of workstation we currently offer.
All right. All right. I would like to thank everybody for their participation. We're receiving quite a few questions. So let's go through more questions right now. For example, here we have a question that says, what's the mechanical maintenance? What mechanical maintenance is required, Johnny, for the robots, I'm guessing?
Got it. So typically after we hand over the project, after project go live, we will provide a very mature customer service program to the customer. And we also gonna sign a service level agreement. Based on the service level agreement, so-called SLA agreement, we will provide the preventative maintenance. Usually biannually, which means twice per year, or maybe some customer really care about the operation, they prefer the 4 times per year, or maybe sometimes they require the monthly maintenance. So of course we can deliver this kind of device services based on the requirement. So the answer is yes, we provide the maintenance service as required. And the only difference for China domestic market and overseas market is in China we deliver the maintenance by ourselves, but for the overseas customers we rely on our foreign partners.
All right, great. I hope our viewers are getting the answers they want. We still have more questions. I'm taking advantage of your time, Johnny, today. We have one more question. If one tote is hit by multiple orders, will the tote be carried in and out again and again?
Jonathan, question again?
So if one tote is hit by multiple orders, will the tote be carried in and out again and again?
Very good question. So basically, this is highly related to the working logic of our robotic system. Mm-hmm. So I think the major logic for our robotic system is to bring as less totes as possible to the picker to hit as many order lines as possible. So it also depends on I think we're gonna do a pre-setup for the algorithm. After we received all the lines from the upper level software, no matter that is from the .ms or SAP, once we received all the lines, firstly, we're gonna do the analysis. Our system, according to the algorithm, will do the analysis firstly. Then it will do we call it order consolidation. Basically, if our system will see the same SKU appears in different orders, then we will group those kind of orders to a certain workstation. Then same logic applies to different workstations, all the workstations. Then after the workstation receive the orders with by groups, then they will send the orders to specific robots to bring the useful SKU to fulfill the order lines. Then this is the basic logic to increase the hit rate. So back to the question, we need to return the codes back and forth. I think after we fulfill this batch orders, batch making orders, then of course, if there's still some pieces left in the toast, yes, we're gonna bring it back to the storage area. But if we will empty the toast, then we will just simply bring it back for future use. We will not return the empty toast.
So following on the same question, how did High System batch these multiple orders to reduce the required amount of totes carried by the robots?
Okay, very good question. So typically we will group, it's highly related to the picking process. So right now for the case study 1, I still remember we set up the average, if that is not peak time, we set up the batch picking as 20 orders for each batch. But if we are talking about the peak time, we're gonna enlarge the batch picking order number from 20 to 120 or even 140. So in this case, which means at one time, in the average time, we're gonna fulfill 20 orders at once. But for the peak time, we're gonna fulfill 120 orders in at once. So it further explained how our robotic system can deal with the fluctuation in the e-commerce, which is one of the major problems for e-commerce industry.
All right. Okay, Johnny. I think we have time for one more question. Because we have a time limit today, the session is just for 1 hour. So let's see. Yes, we have a question. How can I contact you if I want to know more about ACR? Hello?
Yep. I think we have a slides, right?
Yeah, I will tell everybody how you can contact us by the end of this session. It's very, very simple. Let's try one more. What is the standard installation, commissioning, training, and go live time for a project?
All right. So typically for the construction time for our project, as I mentioned several times, it should be within a month for the groundwork. But for the software development and also the API development, typically it takes about 2 or 3 months. But as I mentioned, within this time period, we can also do hardware manufacturing. So from the beginning, from the starting point, if we set up a starting point as the PO received date, then we are looking at 3 months for the 2 to 3 months for the software development, and also the manufacturing, delivering, depends on the location. It will be 1 more month. But I think if we're looking at the overall timeline for the High Robotics solution project, from the PO receiving date to project go live, we're looking at 4 to 5 months, depend on the scale.
All right. Thank you very much, Johnny, for your time and for all your knowledge or the information that you provided today. We have reached the time limit of this webinar. I would like to invite everybody to write us to check our website. You can contact us by email, and also for the questions that we didn't answer, we will contact you. We have your information when you register to this webinar. We will contact you to help you solve all those issues or questions that you may have. Additionally, we will be in close contact with all of you virtually. Here you can see our email, business email or partnership. You can get more information in our website. You can also follow us on social media, on WeChat, LinkedIn, Facebook, YouTube, and Twitter. We will be posting continuously news and also information about our product and our next webinar as well. I would like to thank once again to Johnny for joining us today, and thank everybody for joining us, all the audience. Thank you for your time, and I hope this webinar was useful for all of you. We will send an email at the end of this webinar to all of you with the link to download the materials of this webinar, as well as some product information and a feedback for you to give us your opinion and tell us how we can improve this webinar for the future. Thank you very much. Have a good day. Thank you, Johnny.
Yeah, thank you. Thank you, Jonathan. Thank you, all audience.
That's all for today. Goodbye.
Thank you. Bye.